Okay, so here we'll be looking at the very basics of speed, distance and time. So we all know that speed is equal to distance upon time. So what does this mean? So it could have many implications. Now suppose if we are keeping the time to be constant, so time is constant, then the speed would obviously be dependent only on distance, and in fact it would be directly proportional to distance. Similarly, if we keep distance to be constant, then speed would be inversely proportional to the time, because if we are keeping distance to be constant, then more the time the speed would be lesser, because we are traveling the same distance in more time. So therefore more the time, speed lesser the speed. So this is how we could get the three proportionalities. Okay, so we'll be looking at a few basic questions from this topic in this particular lecture. So here we have been given a person covers a certain distance at a certain speed. If he increases his speed by 25%, then he takes 12 minutes less to cover the same distance. Find the time taken by him initially to cover the distance at the original speed. So let us assume here that initially the person takes time t to cover a distance of s with a speed of v. So this is distance and this is speed. So time is equal to distance upon speed. Now it is given that if he increases his speed by 25%, so the new speed is, so v new is 1.25 into v, which is 25% more than v. Now he takes 12 minutes less to cover the same distance. So the distance is still the same s, but the time has decreased by 12 minutes. So the time becomes t minus 12 upon 60 if we are taking the time in hours, which is t minus 1 upon 2. Pardon, that's t minus 1 upon 5. So now we have been given, now we can simply use this same formula for the new condition. So we'll get t minus 12, let's keep it in minutes right now, is equal to distance upon speed, which is s upon 1.25 v. Okay, so now we have been given, we already know that t is equal to s upon v, so we can write it here, s upon v minus 12 is equal to s upon 1.25 v. Okay, now if we bring s upon 1.25 here and 12 here, we will have s upon v minus s upon 1.25 v is equal to 12. Now if we take 1.25 v as the LCM, we will get 1.25 s minus s, which is 0.25 s upon 1.25 v is equal to 12. Now this could be cancelled out, we get 5 here. So we get s upon v as, so we will get s upon v is equal to 5 upon into 12, 60. Now we had to compute find the time taken by him initially to cover the distance. So we had to compute the original t, which we have already computed. The original t is given by s upon v, so the given answer is 60 minutes. This is the required answer. Now here we have another question. Here we have been given, how long will a train 100 meter long and traveling at a speed of 45 kilometers per hour take to cross the platform of length 150 meter? So let this be the platform. So this is the platform and let this be the train. Now it has been given that the length of the platform is 150 and the length of the train is 100. Now we have to find out the time taken by the train to cross the platform. So let this be the front of the train when it reaches the start of the platform, that would be the start point. And when end of the train reaches the end of the platform, that would be the end. So the total distance traveled by the train would be this distance plus this distance, which is the length of the platform plus length of the train. So the total distance traveled would be 150 plus 100 equal to 250 meters. Now the speed has been given in 45 kilometers per hour. So we first need to convert it into meter per second, so that, because we have been given the distance in meters. So what we can do is, we have been given speed as 45 kilometer is 45,000 meters and 1 hour is 3600 seconds. So we are just converting it into meter per second. This is 12, this is 150. So this again goes by 3 by 50. So this is 4. We get 12.5 meter per second. Therefore, the time taken would be distance upon speed, which is 250 upon 12.5, which is 20 seconds. 20 seconds is the required answer.